Hello, ladies and gentlemen. My name is Zachary Sutter. I'm the spokesman for the Tau Ceti program. As you all know, Earth's condition has grown dire. Global warming has gone rampant, and the sun is baking us alive due to our own inability to reduce carbon emissions, and we're almost at the point of where Venus is at. I believe me and my team of scientists have found a potential new host planet for the human race called Tau Ceti F. Tau Ceti F is 13 light years away and resides in the Ceti galaxy, a spiral galaxy that contains the Tau Ceti system, which is home to a dwarf star. We have chosen this planet because it resides in the habitable zone of this star. Unfortunately, we don't have copious amounts of information of this star due to the fact it's 13 light years away, but we have a plan that will fix that. This will be discussed later in the stages of the plan. As far as time goes, we will be ready to take off in only 10 years, but actually reaching the planet will take about 111 years. Overall, we predict that that colonizing the planet will take over 3 generations, but at that point we'll have a thriving new retreat for the human race. Next, I'll be going over the 3-step plan that we have developed in attempts to get Tau Ceti F up and running. So for stage 1, we have taken the old 2017 version of the German Wendelstein. This was a machine that could perform very short fusion. But we've taken that and we've advanced it to a point where we can create mass amounts of fusion. So the way we're going to power our ship is by taking in hydrogen and helium and fusing it to make almost infinite energy. By doing this, we will never run out of energy, and we can almost change atmospheres and etc. to how we need it. So this is how we're going to get to Tau Ceti, and also we're also going to encase the ship in a heat protective shield, so we will not burn up in any atmospheres. Stage 2 will comprise of us landing on the planet and terraforming it. Fortunately for us, there will be very little terraforming needed because we'll land in a crater and we'll make a biosphere within the crater just for a temporary home until the atmosphere is created through fusion and fusing hydrogen and helium to larger atoms such as oxygen and nitrogen.
My name is Gabo Schlosser, and I'm a geologist that's helping out with getting our human race to the planet Tau Ceti F. Tau Ceti F seems to be more promising out of both Tau Ceti E and F. The thing is, though, is that Tau Ceti F has only been in the habitable zone for about 1 billion years. It sounds long, but it really isn't, because it took about 2 billion years for Earth's biosphere to produce potentially detectable changes in its atmosphere. Earth entered the habitable zone about 100 million years ago, but does not have detectable biosignatures. 2 important rock-forming minerals on Earth are also located on Tau Ceti, which are magnesium and silicon. The ratio of magnesium to silicon is 1.78. The high content of magnesium and silicon in the shallow mantles of Tau Ceti could have a high content of olivine, and the lower mantles could have a high content of ferropericlase. Ferropericlase has been an inclusion in some diamonds. Since ferropericlase is not so viscous, mantle rock would flow more easily, which would have great effects on volcanism and tectonics of the planetary surface, which would have a significant impact.
I'm Cal Ross, and I'm the chemist helping get the human race to the new planet Tau Ceti F. The atmosphere on the planet is very weak, but when we land on the planet, we will use our fusion reactor to help us get to the planet and also use it to disperse oxygen, nitrogen, and carbon into the atmosphere to make this atmosphere stronger and breathable. Not much is known about biotic factors such as plants and animals, but it is suggested that they are present, and helping that will be strengthening the atmosphere, making it stronger using the fusion reactor, and eventually we'll be able to plant seeds and other plant life and help animals survive to help sustain us. The planet is comprised of mostly magnesium and silicon, making the magma under the tectonic plates more viscous and making volcanism more active, and plates move more than the plates on Earth. Also on the planet, there is a metal deficiency on the planet, which eventually later on, many years down in the future, it may affect the human race. But as of when we land on the planet, it'll be able to sustain us very well because of the minuscule population on the planet.
I'm Lane Meyer, and I'm a scientist of ecology. In order for us to survive on Tau Ceti, we will have to bring certain animals from Earth if we're going to survive very long. The first animal would be ants. Ants help out in decomposition more than earthworms. When they dig up the soil, they're recycling nutrients. In a 2011 study, researchers found that wheat crops increased by 36%. The second animal that we would need is birds. Birds perform huge roles in our ecosystem, including forest, decomposition, insect pest control, nutrient recycling, bioindication of an ecosystem's health, and plant pollution. The last animal we would need for our new planet is termites. Termites can decompose plant matter and play vital roles in recycling ecosystems' energy. Without these animals, we wouldn't survive very long on our new planet.
Hello, ladies and gentlemen. My name is Andrew Clinton, and I am a astrologist for the research group that is potentially looking at to colonize Tau Ceti F. So, in astronomy, we like to discuss the habitable zone, which is a zone around a star where liquid hydrogen is supported by a stable atmospheric pressure. The star Tau Ceti is about the same size as our own sun, yet it is also a dwarf star, and it's relatively stable. With no immediate danger of solar winds, it formed about the same way our sun did, from a spinning cloud of gas and dust. The star is about 10 billion years old, which would say it's about the same age as our solar system. Tau Ceti F developed from a spinning planetary nebula following the slow decay of a white dwarf. Over billions of years, the clouds sat dormant until a major explosion of a red giant triggered the collapse of the planetary nebula that formed the star Tau Ceti. After Tau Ceti shone into life, thanks to nuclear reactions deep within its core, the dust grains that were left over from the first solar wind began to clump together under gravity, such as our solar system formed. Over time, these clumps eventually formed planets. This particular planet happened to form right in the habitable zone. Safe to say, it's not entirely done forming, as there is still a lot of dust around the planet. Is there any danger going and settling on this planet? Yes, there's always danger of space travel. Micrometeorites strike millions of miles per second. There's also the potential chance of meeting alien life on the planet, since it is on the habitable zone. There is no signs of extraterrestrial life, however. Extensive research is being done on the planet, but there have been no signs so far.